penuh kesungguhan. Akademi Youtuber Malaysia, rangka laksana dengan jitu, penuh bermisi Guru AYU, mencapai misi yang satu, permisi kita bantu.
Tahniah. Siaran langsung ini dibawakan khas kepada anda oleh Akademi Youtuber Malaysia. Tumpukan perhatian anda. Siaran langsung akan bermula sebentar lagi. Link sijil akan diberikan di hujung siaran ini. Pastikan diisi dalam tempoh yang ditetapkan. Terima kasih.
Hai, Assalamualaikum, salam sejahtera semua. Terima kasih, selamat datang kepada semua guru dan para pelajar yang sedang menyaksikan kelas tuisyen online percuma yang dibawakan khas untuk anda oleh Akademi Youtuber Malaysia dengan kerjasama e-didik Malaysia dan Kelab Guru Malaysia bermula percuma selamanya percuma. Saya Cikgu Hasnitah dari SMK Bagan Jaya, Butterworth, Pulau Pinang akan bersama-sama dengan anda pada malam ini lebih kurang 1 jam untuk satu lagi slot kelas fizik tingkatan 4 dengan tajuknya 5.4 5.4 Refraction of a Wave. Okey, jadi di hujung siaran nanti cikgu akan kongsikan pautan kepada e-sijil express. Anda bolehlah isikan dengan mana-mana email, nama dan nombor kad pengenalan dan insya-Allah sijil akan dihantar kepada anda dalam tempoh kurang daripada 10 saat. Okey, jadi sebelum kita mulakan kelas pada malam ini, ayo kita mulakan dengan Ummul Kitab Al-Fatihah dan bacaan doa belajar. Bagi yang bukan Muslim, anda bolehlah bertafakur mengikut kepercayaan masing-masing. Al-Fatihah. Amin, amin, amin ya Rabbal Alamin. Jadi kita lihat dulu siapa yang ada bersama-sama dengan kita pada malam ini. Kita ada Ciaing di sana. Okey, terima kasih Ciaing. Terima kasih kerana selalu bersama-sama dengan cikgu pada setiap minggu. Okey, siapa kepada yang baru saja masuk, anda boleh perkenalkan diri, nama dari sekolah mana. Okey, sebelum itu cikgu ada kongsikan pautan kepada nota PDF yang untuk panduan murid-murid. Anda bolehlah muat turun, boleh cetak keluar secara percuma saja. Kalau tak sempat cetak, tak apa, anda tengok dulu kelas ini, anda boleh cetak kemudian dan tonton semula video ini nanti bila-bila masa anda lapang untuk mendapatkan jawapan yang penuh. Okey, dan untuk kelas minggu lepas ada sedikit pembetulan yang cikgu buat pada bahagian deskripsi video, iaitu jawapan untuk panjang gelombang yang kita pilih. Anda boleh rujuk semula video kelas minggu lepas, iaitu 5.3 Reflection of Wave. Okey, jawapan yang betul cikgu ada letakkan pada deskripsi video. Anda boleh klik pada timestamp dan lihat di manakah pembetulan yang telah dijalankan. Ya, mana Ciayau, dah lama cikgu tengok dia. Okey, so kalau anda semua sudah bersedia, ayo kita mulakan kelas pada malam ini. Okay, so this will be our discussion for tonight. Okay, cikgu stop sharing dahulu screen cikgu, nanti akan cikgu kongsikan semula. Okay, jadi you can respond to me if you can see my slide. Anda boleh respon cikgu kalau anda nampak slide cikgu, chapter 5 wave 5.4 pembiasan gelombang refraction of wave. Typekan 1 pada live chat. If you can see my slide, please type 1 in the live chat. Okay, thank you very much for your response. Siapa boleh dengar cikgu dengan jelas, boleh type nombor 2. Yes, oh Cik Ayau pun ada. Thank you Cik Ayau. Okay. Suara cikgu jelas ke clear? Kalau jelas boleh type nombor 2. Okay, very good. Okay, everyone, if you are ready and good to go without further ado. Okay, thank you for your response, ya. Okay, jelas insyaAllah, mudah-mudahan malam ini internet semua berjalan dengan lancar. Okay, jadi without further ado, let us begin our discussion with chapter 5, wave 5.4 refraction of wave. Okay, skrin cikgu ni dalam dua bahasa. Jadi siapa yang bukan DLP pun tak ada masalah, boleh join kelas ini sebagai persediaan untuk peperiksaan akhir tahun dan juga kepada calon SPM yang sedang menduduki peperiksaan percubaan. Kalau kertas fizik belum lagi, mungkin ini adalah satu slot ulang kaji yang anda boleh ikuti untuk tajuk ini. Alright? Okay. Okay, let us begin with our lesson 5.4, Refraction of Wave. So, untuk minggu ini kita ada satu saja kelas fizik yang berlangsung, iaitu kelas fizik tingkatan 4. Untuk kelas tingkatan 5 kita berehat minggu ini, tapi kita akan kembali semula pada minggu hadapan bersama Cikgu Rosemawati untuk skor A+ SPM. Tajuk dia tekanan untuk tingkatan 5 Jumaat 9.30 malam. Okay, and this is all the physics members in Physics Panel Akademi Youtuber. Inilah sukarelawan yang ada di Akademi Youtuber, guru-guru fizik yang banyak membantu cikgu menjalankan kelas-kelas tuition online secara percuma bermula dari tahun 2020 hinggalah ke tahun ini. Okey, kepada yang belum lagi muat turun apps Akademi Youtuber di Android anda boleh muat turun pada hari ini juga. Apa yang ada dalam apps ini, dia menghimpunkan lebih kurang 26,000 video PDPC setakat ini untuk pelbagai subjek bermula dari prasekolah hinggalah ke pra-universiti. Jadi kalau anda nak lihat apa subjek-subjek yang ada video di dalam ni, anda boleh download di Android anda dan boleh lihat. Semoga video ini membantu anda mengulang kaji dengan lebih baik. Tingkatan 3 ada tuition tak cikgu? Muah. Okey, siapa nama sebenar anda? Anda boleh check di portal Akademi Youtuber apa subjek yang kita ada. Untuk tingkatan 3 mungkin tak semua subjek, boleh check dekat portal www.academyyoutuber.com untuk ketahui apa tuition percuma yang kita ada buat masa ini. Okay, jadi cikgu harap membantu. Mungkin Cik Ayun juga boleh tolong apa tuition tingkatan 3 yang masih aktif lagi sehingga hari ini. Okay, so boleh check di portal Akademi Youtuber www.academyyoutuber.com. Alright. Okay, so let us begin with our first learning standard, students. So you may sit in the most comfortable way. Prepare with your pen, pencil and so, because later we will do some drawings in this lesson. Kita akan melukis arah perambatan gelombang yang mengalami pembiasan. Okay, so as for our first learning standard, each and every one of you must know how to describe refraction in this following aspect. What happened to the angle of incidence, angle of refraction, what happened to the wavelength, frequency, speed after refraction, and where is the direction of propagation after refraction. Okay. Okay, let us begin with this short animation. Okay. Can you tell me what you can see there? Boleh bagi tahu cikgu tak apa yang anda lihat pada skrin sekarang? Boleh respon. What can you see on my screen now? Okay. What happened to the red car? And where is the red car moving from and to? Yes. Siapa ada jawapan, boleh kongsi. Observe the motion of the car. So how you write observation? Bagaimana anda menulis pemerhatian? Yes, so you can see the direction. Okay, this one, the direction of motion of the car changes as it moves from one medium to another. So the first medium is road, the second medium is mud. Okay, we have a few answer from Akil here. Shallow area. Okay, direction changes. Joris, thank you for joining me. Even though we have discussed this in school, I really appreciate you or your presence here. Okay, so here we see arah pergerakan kereta berubah apabila bergerak dari satu medium ke medium yang lain. Kita belum masuk lagi shallow area, refraction of water wave, Akif. Nanti kita lihat refraction of water wave. Alright. Okay, so this is how we write observation. Okay, so this is how to understand what is a refraction. Okay, so we understand when an object, okay, propagate or moving through two different medium, the direction of the moving object will changes, or the object will changing in direction. Okay, let us see the second example here. Okay, now what happened? Now here we have a light wave. It is entering a medium here, from air to a medium and then went back to air. Okay, and down here we also have a light wave from air entering glass and then went back to the air medium. And here we have a water wave, student, this one. Okay, example of water wave from two different region. Okay, this one involved shallow and deep area, Akif. Okay, so the water wave, okay, from one region to another region, so you can see the direction of propagation changes after it passed through the border. So again, we can see the direction of propagation of wave change as it propagate from one medium to another. Arah perambatan gelombang berubah apabila dia merambat dari satu medium ke medium yang lain. So this is the first understanding on refraction. Okay, now what is refraction of wave? From our observation earlier, what do you say? What can you say about refraction of wave? Akif, Joris, boleh tulis apa yang anda faham. What is refraction of wave? Yes, very good, student. So refraction of wave is the change in direction of propagation of wave due to change in velocity when the wave propagate from one medium to another. Okay, apa itu pembiasan gelombang? Dia adalah perubahan arah perambatan gelombang yang disebabkan oleh perubahan hal laju apabila gelombang merambat dari satu medium ke medium yang lain. Okay, this is the definition for refraction of wave. So the yellow wording is the keyword. Okay, change in direction due to change in velocity when wave travel from one medium to another. Okay, so I hope you get the definition as our first point. Okay, so now let us take a look at a few example of refraction of wave in our daily life. Okay, first, this is the effect of refraction involving light wave. You will see the pencil appear to bend inside the water. Pencil kelihatan bengkok bila dia dirasukkan ke dalam air. Okay, so what happened here? Actually, the speed of light is influenced by the optical density of the medium. Okay, so we understand when the light travel from water to air, its speed or velocity changes. So that will cause the changes in direction. Okay, when it comes out to the air. Okay, so the first example, the speed of light wave, the changes of the speed of light is influenced by the optical density of the water and the optical density of the air. Alright, now in the second example, this one involves refraction of water wave. So when we talk about water wave, the changes in speed or velocity is due to the depth of the water. Okay, this one due to depth. The first example due to optical density of the two medium, because we have two different medium here, water and air. But this one we have the same medium, both deep and shallow region, both water. So the changes of speed is due to the depth of water. Okay, laju gelombang ini dipengaruhi oleh kedalaman air. And the third example, this is refraction of sound wave. Okay, so also we have same medium, both cold air and warm air. Okay, so the difference is the density of wave. The speed of sound changes due to the density of air. Alright. Okay, so in your textbook, student, we have one example of experiment which are using ripple tank to study refraction of water wave for plane wave. Alright. Okay, so this is all the apparatus required and the material as well. So you can read as shown in this screen. Okay. Okay, this is all the procedure. I think later you can read them from number 1 up to number 7, how we do the setup, and finally use a marker pen to mark on the plastic sheet the position of the boundary between the deep and shallow water region, 3 consecutive incident wavefront, and 3 consecutive refracted wavefront. We learned a wavefront before in the previous lesson. What is wavefront? Yes, it is a line joining all point which is in phase on a wave. Yes. Okay. Now, the 8 until step number 10. Okay, so this experiment, first we conducted according to figure 5.41, and then we changed the position of the perspex as shown in figure 5.42. Actually, the reason why we are using perspex sheets here is to create shallow region on the ripple tank. Okay, so when we on the vibrator, connecting to a plane deeper, so a plane wave will propagate from the sources. So this is the region, so it will enter the shallow region. So we will see the pattern and try to draw them. Okay, so here in the second diagram, we start with the shallow region. So the wave propagate from shallow to deep region. All right. Okay, so this will be the observation from this activity. Okay, so for the first diagram, 5.41, the water wave propagate from deep to shallow region. So this is the direction of propagation as you can see in this GIF. In deep region, this is the wavefront. You can see the line that is called the wavefront, student. Okay, and this is how it changes in direction as it enters shallow region. Okay, so if we draw, actually you can use this key DST. It is in Bahasa Melayu, but I don't think you have problem because we are learning in DLP. Okay, duit saya tiada. I'm using this term to represent from deep. D is for deep, S is to shallow, T is towards. Mean from deep to shallow, the water wave refract towards the normal. Okay, towards the normal. Okay, so this is the wavefront in the deep region. Okay, the distance between two wavefront is actually give you a wavelength. Okay, jarak antara dua muka gelombang adalah panjang gelombang. Okay, and you can see the wavelength decreases in shallow region. So we draw the line closer. Okay, before we should know where to draw the normal. Okay, the red dashed line represent the normal. What is normal? Normal is a line 90 degree to the boundary of the deep region and shallow region. Okay, so since from deep to shallow, the water wave propagate towards normal. So we draw this line closer to the normal. So you will see the angle of incidence here is greater than the angle of refraction. So we understand when water wave propagate from deep region to shallow region, it refract towards the normal where the angle of incidence greater than the angle of refraction. Are you doing good so far? If you can follow me, you can type 3 in the chat. Kalau anda boleh ikut cikgu sehingga ini, anda boleh type nombor 3 pada live chat. Or if you have any question, you can write there as well. I will try to respond to you as soon as possible. Okay, now we look at the second. Okay, at the second arrangement, figure 5.42. Okay, now the wave started propagate from shallow to deep region. So this is the keyword. Okay, wavelength decreases just now. From shallow to deep, the wavelength decreases. Okay, I show you again. Okay, from deep, okay, the first example from deep to shallow, the wavelength decreases. Okay. Yeah, shallow deep away, betul. Shallow deep away. Okay, so from deep to shallow, it is towards. Duit saya tiada. Deep, shallow, towards. So the wavelength decreases. Okay, so ini Muhammad Nuruddin, deep to shallow decreases ya. Increases itu when shallow to deep. Kita tengok nanti yang kedua. Okay, the second example students. Okay, second example. Okay, now we started the propagation from shallow to deep region. Kita mulakan pembiasan dari, kita mulakan perambatan dari kawasan cetek kepada kawasan dalam. Okay, so ini cikgu gunakan, saya dapat ampau. Tadi duit saya tiada, sekarang saya dapat ampau. Shallow to deep away, itu maksud dia SDA. Shallow, when water wave propagate from shallow to deep region, it will be refracted away from normal. So kalau anda lihat GF di atas, alright, so this is how it be. From shallow region, you can see the wavefront is closer to one another, showing that the wavelength in shallow region is shorter. Okay, while in the deep region, see the wavefront is further from one and another, showing that the wavelength in deep region is longer. Okay, so kalau kita lukis, okay, this is the wavefront in shallow region. So how to draw the wavefront in deep region? So first you must mark where is our normal line. Okay, wavelength increases from shallow to deep. Yes, sleepy sharp. Right? Okay. So this is the wavelength in shallow region. It says shorter. So this is our normal, the blue dotted line. Again, what is normal? It is a line 90 degree to the boundary between the shallow and deep region. So if you mark, this is our angle of incidence, students. Okay, if we mark, this is our angle of incidence, I. Okay, what is angle of incidence? It is an angle between the incident wave and the normal. Okay, so since it is refracted away, so it will move away from the normal. So this is our angle of refraction, which means if refract away, our angle of refraction should be greater than angle of incidence. Yes. So the red line shows the wavefront in the deep region. So when you draw, at least you must draw 3 wavefront. Ini syarat dia. Kalau anda nak lukis, sekurang-kurangnya 3 muka gelombang. Tak boleh kurang. Lebih tak apa. Jangan kurang daripada 3. And make sure when you draw, the distance increases, showing that the wavelength increases. Alright? Okay. Ya, Nazuhar, sebab shallow dia kecil wavelength, deep bigger wavelength. Okay, correct, betul. Okay, faham Okay, thank you very much. Alhamdulillah, faham. Okay, so tadi apa kita punya keyword tadi? Duit saya tiada. From deep to shallow, refracted towards normal. Then saya dapat angpau. From shallow to deep, refracted away from normal. In shallow region, the wavelength is shorter. In deep region, the wavelength is longer. So what can you tell about the speed or the velocity of wave? So when the wavelength shorter, showing the speed also lower. When the wavelength longer, showing that the speed also higher. Alright? Okay. What about the frequency, student? Does the frequency change from deep to shallow or from shallow to deep region? What can you say about the frequency? Adakah frekuensi berubah atau tidak? What happened to the frequency? Yes, the frequency remain, the frequency unchanged. Frequency tidak berubah. Kenapa? Sebab gelombang adalah daripada sumber yang sama. Okay, because the wave is produced from the same sources of the ripple generator. So frequency unchanged. Yes, frequency remain the same, no change. Alright, very good. Okay, we go to the next slide. Okay, next slide, students. So this is the conclusion from what we observe from this activity. So you can name all the characteristics. Okay, the angle of incidence, angle of refraction, what happened from deep region to shallow region. Okay, since the wave refracted towards normal, so R smaller than I. Alright, and from shallow to deep region, since it is refracted away from normal, so R is bigger than I. Okay, the wavelength from deep to shallow decreases, from shallow to deep increases. The frequency unchanged because produced from the same sources Then the wave speed from deep to shallow decreases, shallow to deep increases. And for the direction, you can say from deep to shallow, refracted towards normal. Okay, deep, shallow, towards. Duit saya tiada. Okay, and then from shallow to deep region, it is refracted away from normal. Saya dapat ampau. Alright. Okay, so that conclude our first learning standard. I hope you're clear with that. Okay, now let us continue with the second. Okay, this is important. You must know how to draw the diagram to show refraction of water wave into different depth. Okay, so you understand the concept. Now is to draw. Okay, to interpret the concept into drawing. Okay, so this is for instruction to guide you how to draw. Kalau anda cetak nota cikgu ni, anda ada, I prepare a diagram for you to draw. Ada satu gambar anda boleh lukis. So later you can print out and complete your diagram. Okay, so first you have to draw. Okay, this is the diagram you are given. So this is our incident wave. It is from deep region to shallow region. Okay, so first you have to draw line AB perpendicular to the incident wavefront. Okay, this is the first we do. Okay, now step number 1, we draw line AB perpendicular to the wavefront, so it until this point. Okay, AB. Okay, second, what we do, we draw the normal, which is perpendicular to the boundary of the deep region and shallow region. So this is the boundary. We draw normal, which is 90 degree to the boundary. Okay, second step, easy, right? Okay, then the third step, you have to draw arrow line BC. This is the arrow line BC, which represent the direction of propagation of the refracted. So AB is our incident wave and BC is our refracted wave. So from the earlier discussion, we understand from deep to shallow, it refract towards normal. Okay, deep, shallow, towards normal. So it's refracted closer to the normal. Okay, so the last step, you must draw at least 3 lines, okay, perpendicular to BC to represent the refracted wave. So here I draw 3 lines. Okay, minimum 3 line, okay, not less than that. And when you draw, make sure it is closer to one and another compared to the incident wave, showing that the wavelength decreases in shallow region. Alright, so I hope this step clear so you can practice in this page. Tips dia, buat normal line dulu ke? Yes, boleh buat normal line dahulu, okay, ataupun follow yang tadi ni. Kalau yang tadi ni normal line, itu second step. Okay. First step, draw incident wave first. Okay. 90 degree to the wavefront, 90 degree to the incident wave until it hit the boundary. Then you draw the normal line, it meets point B at the boundary. Okay, ataupun kalau anda nak lukis normal line dulu, tak ada masalah. You can draw the normal line first and then you draw the incident wave. Okay, you draw the direction of propagation of the incident wave, but make sure it meet the normal line at the boundary. So you know where to mark the angle of incidence. So kalau kita tandakan titik dia ada di sini. So angle of incidence must be between the incident wave and the normal line. Okay. Dan sini kita punya angle of refraction. Here is our angle of refraction. So are you clear, Nazuha? Am I answering your question? So it's up to you. You want to draw the normal line, also no problem. You want to draw the direction of propagation of incident, no problem. Tapi yang penting ini, dia mesti jumpa dekat sini. I must be exactly between the incident wave and the normal. Alright? Okay. Okay, so you can practice here. Anda boleh kertas kosong, kalau ada ambil pensel, ambil pembaris. Okay, you can draw this shape. So this is the deep region, this is the shallow region. Second drawing, we started from shallow region to deep region. So just use my tips. Deep to shallow, duit saya tiada, it should be towards normal. Okay, and then here from shallow to deep, saya dapat ampau. Shallow to deep should be away from normal. Okay, so kalau anda practice, kita ikut step tadi 1, 2, 3, 4. So first we draw this line. Okay. Direction of propagation of incident wave. Okay, then second we draw the normal. Okay. So you see this is our angle of incidence. Here is our angle of incidence. Okay, angle of incidence here. Okay, cikgu tak boleh fokus. Okay, I mark first the angle of incidence. It is here. Okay, here. I. Angle of incidence, I. Okay, then next, third step. Our third step. Yes, we draw the refracted line, the refracted wave, and finally we draw the, okay, at least 3 line. So from deep to shallow, away from, refracted towards normal, and you can mark your angle of refraction as well. So here is our angle of refraction, which is smaller. Why smaller? Because it refracts towards normal. Faham Okay. So who's clear with the first drawing? You can type 5 in the live chat. Siapa faham lukisan ini, boleh follow, anda boleh type 5 pada live chat. Okay, then second, you can sketch on a white paper, A4 paper, and try to draw the refracted wave on the deep region. Just follow step number 1 until step number, okay, Sleepy Shah, thank you for your response. Okay, boleh cuba lukis. Cikgu bagi anda sedikit masa untuk selesaikan lukisan yang kedua. 1 minit cukup? I think enough, should be enough. Okay. Okay. So let us see what is the come out, apa hasil lukisan yang kedua ini. Okay, where is my mouse? Mouse cikgu pergi mana? Okay. So first, okay, this is the first step. Okay, guna yang inilah tadi. So the first step, okay, we draw the direction of propagation of the incident wave. Second, we draw the normal as shown here in the black dash line. Okay, then from shallow to deep, just now we understand from shallow to deep it should be refract away from normal. Dia dibiaskan menjauhi normal. So dia pergi ke atas, away from the normal. Alright, so you can see angle of refraction is greater than angle of incidence. So where to draw the refracted wave, you draw at least 3 line. Okay, walaupun sini dia banyak, okay, minimum anda kena lukis 3 saja. Tak lukis sama banyak pun tak mengapa. It doesn't mean here it show 10 line, here also you must show 10 line. No, at least you draw 3 refracted line, minimum 3 refracted wave. So here you see the wavelength decreases and this side the wavelength increases in the deep region. Okay, so ini dia punya formula. Saya dapat ampau shallow to deep, refract away. Deep to shallow, refract towards normal. Alright, okay. Okay, so now the third learning standard. I think we are moving very fast now. Explain natural phenomenon of refraction wave in daily life. Can you give some examples, student, of natural phenomena involving refraction of wave in our daily life? Boleh bagi cikgu beberapa contoh, satu contoh. Satu orang bagi satu contoh natural phenomena, kejadian semula jadi yang kita boleh kaitkan dengan pembiasan gelombang. Tak kira lah gelombang bunyi ke, gelombang cahaya ke, gelombang air. It doesn't matter what kind of wave, but at least as it is refraction, you can give that example. Dekat mana anda boleh lihat berlakunya pembiasan gelombang, where you can witness refraction of wave occur in our daily life. Okay, Nazuha, Slipsha, kita ada Joris here. Okay, Ciaing, are you still there? Okay, kalau ada boleh bagi contoh. Okay, so kita tengok. Okay, this is one simple example. Salah satu contoh. Okay, an object appear to be like example when you went into swimming pool, bila anda masuk dalam kolam renang, you appear to be shorter. Anda kelihatan lebih pendek, lebih rendah daripada ketinggian yang sebenar. Or you will see the cone appear to be closer to the surface than the real depth is. Okay, ini another example. This is the observer. Okay, actually the fish is a bit at the front, but he will see the fish appear to be behind the actual fish. Okay, this is due to refraction of light wave. This one also due to refraction of light wave. So what happened here? Light rays originating from the coin bend or refract. Okay, you can see here. Okay, so we can draw two light ray from the object. Okay, from the object. So from water to the air, so it will be refract away from normal because water has higher optical density compared to air. So from higher to less dense density, so it will refract away from normal. So as light travel in a straight line, so you will see the image of the coin appear to be closer to the surface. Okay, the image of the coin appear to be closer to the surface. Same thing happen here. Okay, we can draw two light ray from the actual fish. So when come out from the water, it will be refract away from the normal and entering the eyes of the observer. So when we draw a straight line from here, this is where the image of the fish appear at. Okay, a bit behind the actual one. Okay, this is another example, refraction of sound wave. If you notice, you can hear sound clearly at night, but not so at day. Why? There is a difference between the volume of sound we are hearing at night compared to at day, even though we are setting the same volume on the sources or the radio as well. Okay, so this is what happened at day, student. Why sound cannot be heard over a longer distance on a hot day? So how to explain this? Number one, you can say on a hot day, so the air layer near the surface of the ground is warmer, okay, hotter. So we use warmer better. Okay. So what happened? So the density of warmer or hotter air is lower compared to the density of the cold air above. Okay. So here, sound wave travel faster in warm air because sound wave travel faster in low density. All right. Okay. Then sound wave travel from warm air to cold air above. So what happened? The speed of sound decreases. Okay, speed of sound decreases. So by this, the sound refracted away from the ground. Bunyi dibiaskan menjauhi permukaan tanah. So kalau dia keluar dalam Section A, if this question come out in Section A, dia maximum 3 marks. Tapi kalau dia keluar in Section B in essay, normally 4 marks for the explanation. So each mark represent 1 point. Each point represent 1 mark. Setiap point ni dia mewakili satu markah. Alright, so first you tell the layer on the ground is warmer, or the layer near the surface is warmer, 1 point. Lapisan udara di permukaan tanah lebih panas. Okay, then second point, sound wave travel faster in warm air. Gelombang bunyi bergerak lebih laju dalam udara panas. Then the third point, sound wave travel from warm air to cold air. Okay, bunyi bergerak dari kawasan udara panas ke kawasan udara sejuk, maka laju bunyi berkurang. The speed of sound decreases. So bunyi dibiaskan menjauhi permukaan tanah. So dia tak sampai kepada pendengar sebab dia naik atas. Alright, so that's why we hear a soft sound on daytime. Okay, then but what happened at night? Apa berlaku semasa malam? Why sound can be heard clearly over a long distance on a cold night? Okay, pada malam kita dengar bunyi dengan lebih jelas, lebih kuat. So this is what happened. And again, the first point you talk about the layer of air on the surface of the ground is cooler. Okay, at night the ground's cold, air layer the ground is cooler. Okay, pada waktu malam udara di permukaan tanah adalah lebih sejuk. Alright, then what happened? Sound wave travel at low speed or slower in cold air. Gelombang bunyi bergerak lebih perlahan dalam udara sejuk. Then third point, sound wave travel from cold air to warm air. So the speed of sound increases. Okay, udara bergerak dari kawasan udara sejuk ke kawasan udara panas, maka laju bunyi bertambah. So by this, sound wave refracted towards the ground, maka udara dibiaskan menghampiri permukaan tanah as shown in this diagram and this GIF as well. Alright, okay. Okay, the third example. Okay, third example, you can see why wave become closer to each other and follow the shape of a shoreline when they are approaching the beach. Bagaimanakah kalau kita tengok this is the wave front okay, at the deep region. Okay, gelombang dia lebih panjang. Okay, ditunjukkan oleh jarak permukaan gelombang yang jauh. Okay, the further distance between the wavefront showing that the wavelength of the water in a deep region is longer. So as it approaching the beach, you will see the wavefront decreases. Okay, showing that the wavelength decreases in shallow region. Okay, it's explained here. Away from the shoreline, wavefront of the water almost straight and parallel because water wave move at uniform speed. Okay, but now what happened here? So here you see two lines, student, the yellow line and then the green line. Okay, if you see the yellow and the green. So the yellow line, this is actually the wavefront at the bay pada kawasan Teluk, and the green line showing that the wave at the Cape. Ini bentuk gelombang pada kawasan Tanjung. Okay, the Cape. This is the bay. Okay, so what happened here? The Cape is shallow. Okay, the Cape is a shallow water region while the bay is a deep water region. Kalau you compare, okay, Cape and bay. Alright? Okay. Tanjung lebih cetek, Teluk lebih dalam, this one. If you compare the Cape and the bay. So when the wavefront of the water propagate to the Cape, the speed of the water wave decreases, causing the wavelength to be shorter. Okay, then wavefront of the water approaching the bay move at higher speed and the wavelength is longer. If you compare the wavelength at the bay and at the Cape, at the bay is longer, at the Cape is shorter. So this caused the wavefront to curve and follow the shape of the shoreline. Soalan ni dia tanya kenapa apabila air laut menghampiri pantai, bentuk dia itu mengikut bentuk permukaan pantai. So this is the explanation we can give for that. Why the wave follow the shape of the shoreline as it is approaching the beach. So the first point, second point, and third point. Alright, okay, next. Okay, now again we compare the Cape and the bay. Why the water at the Cape has high wave? Kenapa ombak dia lebih kuat di kawasan Tanjung berbanding dengan kawasan Teluk? So here we can see the shape. Okay, more energy is converged at the Cape since it has convex shape. Okay, so at this area, the wave is converged at a point. So the energy is focusing at one point. So the energy will be bigger. So bigger energy will create bigger amplitude, mean high wave. Okay. Then here what happened at the bay? The bay has a concave shape. Okay, it has a concave shape. Okay, it's given here. The energy at the bay, which has concave shape, so it is spread. It will be a spread. Okay, concave shape is a diverging lens if we learn later in chapter 6. So the energy of the wave here will be spread out, which means less energy. So that's why the wave at the bay is more calm compared to the wave at the Cape area. Okay, as shown here. So water wave at the bay has low amplitude, low energy. So if you are asked to build a jetty, so where you should build it? At the Cape or at the bay? So from this reason, we will choose bay to build the jetty because the wave there is more calm. So it won't destroy the jetty you are building. Alright, so I hope you are clear with the difference between the cape and the bay. Okay, again student, this one another example. So this is what we see just now, refraction of water wave from deep to shallow region. Okay, this is from the side view. Ni dari pandang sea. Okay, sorry. So this one from the side view. Okay, you can see in the shallow region, the wavelength is shorter. Okay, and in the deep region, the wavelength is longer. So do the speed. At shallow region, the speed is lower. At deep region, the speed is higher. Okay, so what if we take a short break for a while? We will come back after this. Kita berhenti rehat seketika. Kembali lagi sebentar lagi. Jangan ke mana-mana, sekejap sahaja. Okey. Sementara itu kalau anda ada soalan nanti boleh tanyakan pada live chat. Okay, see you. Okay. Kembali lagi bersama saya Cikgu Hasnitah. Welcome again to our free online tuition for physics form 4 brought to you by Akademi Youtuber Malaysia, Kelab Guru Malaysia and Didik Malaysia. Bermula percuma, selamanya percuma. Okay, sebelum itu kita ada Mr. P di sana. Okay, thank you very much for supporting me tonight, Mr. P. Terima kasih. Cikgu Mr. P adalah salah seorang juga presenter yang bersama-sama dengan saya. Cuma sekarang beliau sibuk sikit dengan silibus baru tingkatan 6. InsyaAllah selepas ini kita akan kembali lagi bersama-sama dengan Mr. P. Okay, thank you for your support, Mr. P. Okay, students, so we are about to finish. Now we are entering the fourth and the final learning standard. Kita masuk ke standard pembelajaran yang keempat dan terakhir untuk tajuk ini. Okay, tadi anda sudah lihat the characteristic. We have also practiced on how to draw the diagram for refracted water wave and also example of natural phenomenon involving refraction of wave in our daily life. So now let us see some example of question. Also past year SPM question involving refraction of wave. Okay, so let us do this together. Before that, those who are just joining us, again, you can find the PDF copy for this module. I have pinned it in the live chat, so you can click the link later on to get your copy, so you can keep it digitally or you can print them out as well. So I hope it helps you to understand this topic in a better way. Boleh jadikan sebagai bahan tambahan selain daripada bahan yang cikgu anda berikan di sekolah. Alright, okay, so to begin, let us study this formula. We've learned this earlier in this chapter. Formula for wave speed. V is the wave speed equal to F lambda. F is the frequency of the wave and lambda is the wavelength. So how to use this formula involving refraction of water wave? So this is in deep region, the wavelength lambda 1, this is the wave speed V1, and in a shallow region lambda 2 and the wave speed is given by V2. So if we rearrange this formula, okay, and since frequency is remain, okay, so from here we come up with this formula V1 equal to lambda 1, V1 over lambda 1 equal to V2 divide lambda 2. Okay, mean the frequency of the wavelength in the deep region equal to the frequency of the wavelength in the shallow region. Okay, how to apply? Let us take a look at this question. Okay, can you tell me which one is the correct answer? Okay, mari kita hitung bersama-sama. Diagram show, but I'm sorry this question is in Bahasa Inggeris, but later the structure and essay will be in Dewey language. Alright. Okay, diagram show refraction of waterway. So you can see the water propagate from deep to shallow region. Given the wavelength in deep and shallow region, 3 centimeter and 1.5 centimeter respectively. So you need to find the speed of the water wave in the shallow water region. So how to find? Yes, use the equation I showed to you just now. So this is the equation V1 divide lambda 1. This is the speed and the wavelength in deep region. equal V2 divide lambda 2. This is the speed and wavelength in shallow region. So second step, substitution. Okay, so V1 is 5, it's given here. And lambda 1 is 3 in diagram. V2 we are looking for, and lambda 2 is 1.5. So this is a very simple mathematics. So answer. Okay, who's done can share your answer in the live chat. Are you done, Joris? Are you still there? Sharing. Sleepy Shah, Nazuha. Apa jawapan dia? Siapa lagi yang ada tadi? Muhammad Nuruddin, if you still there, can you tell us which one is the answer? A, B, C, D. Akif Zafran. Okay. Mana jawapan dia? Okay, Joris say 2.5. Okay, 2.5 centimeter. Is it 2.5? Let us check. Okay, very good, Joris. So answer is number 2. We don't have A, B, C, D here. We have 1, 2, 3, 4. So answer is number 2, 2.5 centimeter per second. Okay, well done, Joris. Okay, now this one. Okay, now you are given diagram 3. This is taken from SPM 2006 to the long time ago. I think you still not born yet at that year. Am I right? Okay, I think you are born on 2009. Is it? Or some of you are born on 2008. Okay, which of the following patterns can be seen on the screen? So this is the vibrator. When you switch it on, so we understand the water wave propagate from shallow region here to deep region. So how is the wavefront in shallow region and the wavefront in deep region? So which one is the answer? Okay. You can reject B because it shows uniform wavefront. It can be because the wavelength is different. So B is rejected. Okay. So do D, you can reject. Okay, D also rejected. So which one? Either A and C. So the answer should be, Jory say A. Do you agree with him, students? Others? Yes, so answer is A. Correct. So this is the wavefront in the shallow region showing the wavelength is shorter. This is the wavefront in deep region showing the wavelength is longer. So the wavelength increases from shallow to deep region. Okay, next, number 5. This is similar, a bit similar to question 4. Now we have tilted basin contain water. So it tilted in this way and we drop the water at the center of the basin. So on the left is a deep region, on the right is a shallow region. So how is the wavefront will be look like? Is it A, B, C, or D? So which two you can reject? You can reject B and D, students. So you have two choices left, either A or C. So we understand in deep region, the wavefront should be longer. In a shallow region, the wavelength should be, the wavelength is shorter. So this one, again, answer is A. Okay, good. Next, okay, now the structure question. Okay, you are given this diagram. Actually, I took this from your textbook, so you can refer that. Diagram show propagation of water wave from region P. So we understand region P. We can say it is deep region. How we know? Because the wavelength is longer. Okay, to Q. So Q, we understand Q should be shallow region because the wavefront is closer, which means wavelength is shorter. So given speed of wave in region P is 18 centimeter per second. So find the speed of the wave in region Q. So according to our understanding, the speed of wave in region Q should be, smaller than 18 centimeters because the speed decreases from deep to shallow region. Okay, so how to find? So this is draw to help you to find the wavelength. Okay, so how to find? So first you have to find the wavelength. In region P, the wavelength is 3 cm. How we know 3 cm? So here you can draw how many lambda you can see there, student. Okay, you can see this is the first lambda. Okay, this is the second lambda. Okay, this is the third lambda. And this is the fourth lambda. So we have 4 lambda there. So total length is 12 centimeter from this end to the other end. So 12 divided 4. So the wavelength is 3 centimeter. And we do the same thing in region Q. Okay, you can see there are 8 lambda in region Q. So 12 divided 8. So it gives you 1.5, the wavelength. So from here, you can use this equation. V1 over lambda 1 equal V2 divide lambda 2. So this is the substitution. So we find the speed of wave in region Q is reduced to 9 centimeter per second. So this proved to us in deep region, the wavelength is longer and so do the speed higher. In shallow region, the wavelength is shorter and the speed is lower. Alright? Okay, good. Okay, next question. Okay, next question. We have P and Q. Now, this is the border between deep and shallow region. The green dotted line show the normal. This is the incident wave. Okay, this is the lambda in the deep region. So the question asks you to calculate the wavelength. Calculate what is lambda shown in this diagram. They give us the frequency of the wave, student, and the speed in the deep region is 30 centimeter per second. So actually A is a very direct question. So you can use formula. Yes, V equal F lambda. So we use this. So the speed is given 30 centimeter per second. Frequency is given 10 hertz. So we can find what is lambda. So lambda is, yes, 3 centimeter. Panjang gelombang 3 centimeter. Okay, now find the speed of water in a shallow region if given the wavelength is 1.5 centimeter. Okay, so how to solve B? Okay, I give you 30 seconds to solve B and share your answer in the live chat. Okay, cuba kira bersama-sama. If you are still there with me, let us solve B together. Find the wave speed of the water in shallow region if given the wavelength is 1.5. Yes, so this is actually you have option here. You can use this formula. V equal F lambda. We know F is 10, the frequency 10. Lambda is 1.5. So we can find the speed 15 centimeter per second. Okay, you can also use the V1 equal to lambda 1 equal to V2 over lambda 2. Boleh juga guna yang itu. Okay, so I show you again the final answer for B, 15 centimeter per second. Okay, so again we understand when the water travel from deep region to shallow region, the speed decreases from 30 centimeter per second to 15 centimeter per second. So do the wavelength decreases from what is the wavelength just now? From 3 centimeter in deep region to 1.5 centimeter in shallow region. But the frequency remain because the wave is produced from the same source. Okay, now this one, student. Using arrow, draw direction of propagation of the wave in the shallow region and sketch the wavefront of the water wave in this region. So this is again maximum. We draw 3 wavefront. All right, so from deep to shallow, it refracts towards normal, where the angle of refraction is less than the angle of incidence. If they ask you to mark the angle, make sure you know where to mark correctly. This is our angle of incidence. Okay, and this is our angle of refraction. Sorry, okay. It is over the normal line. So you must draw, please make sure you draw exactly between the normal and the refracted ray. So this is this is R, angle of refraction. Alright? Okay. So compare the frequency, compare the wavelength, and compare the speed. So there are 3 comparison you have to make for the deep and shallow region. So frequency, same, or you can say unchanged, remain. Wavelength in the deep region is greater than that in the shallow region. Wave speed in deep region greater than that in shallow region. Okay. So our next question. Okay, this is also SPM trial. This is from SPM trial paper. but I don't remember from which state. I think from Pahang if I'm not mistaken, but I don't remember which year. Okay, diagram 3.1 shows a spoon in a cup of water. So you can see this is the effect of refraction of light. The spoon appear to bend in a glass of water. So first, name the light phenomenon involved in this diagram, student. So what is the name of the light phenomenon? Apakah nama fenomena cahaya? Refraction. You can say refraction, refraction of wave, or refraction of light. Refraction of light wave. Pembiasan gelombang cahaya, pembiasan cahaya. Alright. Okay, then explain how the light phenomenon occur. Bagaimana berlaku pembiasan cahaya. So you can write this. Number 1, 2 marks. First, we can say light propagate from low optical density medium to high optical density medium, from air to water. Alright. Second, so the speed of light decreases in high optical density medium and refracted towards normal. Alright. Okay. Next question. Okay. Now, involve refraction of sound wave. Okay. This is also SPM collection paper long years ago. Okay. Diagram A shows a boy beating a drum, produces sound which can be heard by the man. Okay. And first question, what type of wave is sound wave? We learned this in 5.1. Type of wave. So sound wave is longitudinal wave. Okay, longitudinal wave. Okay, next, explain how sound is produced by the drum. Can be heard by humans' ears. If you download the PDF copy I shared to you, you just have to fill the blank spaces here. So I make your work easier. You don't have to write everything here, just some blank spaces. I think number 1, you have to write parallel. Okay, when the drum vibrates, a particle vibrates parallel to the direction of propagation of the. This shows sound wave is a longitudinal wave for our first point. Second point, you have to write compression and rarefaction only. Kawasan mampatan dan regangan terhasil. Okay, compression and rarefaction region produced alternately. Okay, compression region is where the air particle is closer to one and another, and rarefaction is where the air particle is further to one and another. Okay, then energy is transferred from the drum to human ears. So energy is transferred from the source producing the sound wave to the observer, the human ears. And finally, our eardrum vibrates and we able to hear the sound produced. Akhirnya gendang telinga bergetar dan mendengar bunyi yang terhasil. So for point 4, you have to fill the blank spaces with the word vibrates. Kena isi tempat kosong dengan bergetar. Alright? Okay. So next student, okay, this one. Diagram show sound wave produced by a boy singing at a distance to his camp. If we relate to our discussion earlier, we can hear sound clearly at night compared to at day over a long distance. Okay, first, what is meant by longitudinal wave? So we understand sound wave is longitudinal wave. So what is longitudinal? Cikgu, kalau soalan essay macam ni jawab dalam bentuk point, dia accept tak ada masalah, boleh. Boleh letak nombor 1, nombor 2, nombor 3, nombor 4, tak ada masalah. Nak guna 1 Roman, 2 Roman, 3 Roman pun tak ada masalah. Nak guna point, dash pun tak ada masalah. Okay? Okay, boleh Okay. Macam tadi pun cikgu bagikan jawapan mengikut point. The first point, first mark. Second point itu dapat second mark. Okay, this one. What is longitudinal wave? Boleh jawab tak soalan cikgu Nazuha? Apa maksud gelombang membujur? Ingat 5.1, longitudinal wave. Okay, longitudinal wave is a wave where particles of the medium vibrate in the direction parallel to the direction of propagation of the wave. Zarah medium bergetar pada arah yang selari dengan arah perambatan gelombang. Okay. Okay, next. Okay. Next, give one reason why sound can be heard louder at night. Bagi satu sebab mengapa bunyi didengari lebih kuat pada waktu malam. Okay. Macam soalan Nazuha tadi ni, soalan cikgu yang sebelum ni, kalau nampak kan soalan yang 4 markah ni, tengok cikgu tuliskan ikut poin. Poin yang pertama, ini poin yang kedua, poin yang ketiga, maksudnya cikgu tak buat dia dalam satu perenggan. I am not writing my answer in a paragraph. Satu, dia bagi advantage, senang nak tengok dekat mana poin kamu, senang kita nak baca jawapan anda. Kalau semua bersambung dalam satu perenggan, susah. Terutamanya kalau tulisan anda sangat kecil ataupun tak kemas. So better you separate your answer. This is the first, second, third, fourth, fifth and so on. Boleh Okay. Okay, we go back to this question. Mengapa? Because sound wave is refracted towards the ground. Kerana bunyi dibiaskan ke arah gelombang bunyi, tambah perkataan gelombang di sana. Gelombang bunyi dibiaskan ke arah permukaan tanah. Dia nak satu sebab saja. So kita tak perlu tulis panjang sebab satu markah saja. So we just say the sound wave is refracted towards the ground. Okay, next. Okay, now 10 marks essay question. The last question for this evening. Okay. Soalan ni sebenarnya boleh jadi advantageous. It can be disadvantageous if you are less reading. Kalau anda biasa practice, soalan ni boleh bantu anda untuk mengutip markah, to score mark for paper 2, either in section B or in section C. So for this kind, this is given in section B. Alright, question 9 and question 10. Okay, you are given 4 types of retaining wall. We have W, X, Y and Z, and they give us 4 aspects. The location of the retaining wall, kedudukan dia di mana, at the bay or at the cape. So you have 2 choices there. And then the structure of the retaining wall. Okay, we have 2, first structure, W and Z has the same structure, sloping retaining wall. And then X and Y has a vertical, dia tak slope, dia vertical retaining wall. Okay, and then for the surface of the retaining wall, we have 2 choices as well. Smooth surface for X and Y, permukaan yang rata, licin, and then uneven surface, permukaan yang tidak rata for W and Z. So 2 choices. And then for the height of the retaining wall, W and X has a high retaining wall, you boleh nampak tinggi, dia punya tembok penahan tu tinggi, while for Y and Z it has low retaining wall, dia punya tembok lebih rendah. So bagi setiap aspek they give you 2 choices. In some question there might be 3 choices, so you have to choose one best option for each character. Okay, so imagine you are as an engineer, you are give a task to design a new harbor to be built. Okay, so this table will help you to choose your design. So you have to justify the location and characteristic of the retaining wall and choose the most suitable type of retaining. Anda kena bina satu tembok penahan berdasarkan ciri-ciri yang diberi. Okay, manakah ciri-ciri yang paling sesuai? Okay, so first and foremost, I always advise the student to answer this in a form of table. Jawab dalam bentuk jadual. Tidaklah wajib tapi membantu anda menulis jawapan dengan lebih baik. So anda tidak merepek kalau anda tulis panjang-panjang dalam bentuk perenggan. Okay. And also easier for the marker to see where is your point at. Senang pemeriksa nak tanda, nak beri markah. Okay, so the first column, terpulang, you nak buat 2 kolom, 3 kolom tak ada masalah, tapi selalu saya buat 2 kolom saja cukup. Okay, ada cikgu dia prefer 3 kolom, tak ada masalah. Okay, so first characteristic, you write back all the aspect given, location of the retaining wall, structure of retaining wall, surface of retaining wall, height of retaining wall, and finally you write which one we chose. Okay, so location where? At the cape or at the bay. Tadi kita belajar kan, at the cape has a high wave. Takkan kita nak bina di sana. Bina hari ini mungkin lagi sebulan 2 akan runtuh. Okay, so we build it at the bay because the wave there is more calm. Okay, reason, calm wave, low energy wave. So kita punya tembok tu dia tak mudah, dia tak rosak, dia tak musnah. Alright, and then the structure of the retaining wall. So we have 2 choices. sloping or vertical, bercerun ataupun dia vertical. So we choose sloping retaining wall. Why? So it is thicker at the bottom to withstand high pressure of the water at the bottom, supaya dia lebih tebal di bahagian bawah untuk menahan tekanan air yang tinggi. Kerana kita faham tekanan air bertambah dengan kedalaman, water pressure increases with depth, so it has to be thicker at the base of the wall. Alright. And then the surface, smooth or uneven, student, which one? So we choose uneven surface. This is to prevent erosion of the retainer. Kita nak elakkan dia terhakis. Kalau permukaan dia rata, dia akan terhakis dengan mudah. So the reason, wave reflected in many direction. Okay, so the wave will be reflected in many directions. So this is also to prevent erosion of the wall. Alright, and then the height of the retaining wall, obviously yes, we choose a high retaining wall. Kita pilih tembok penahan yang tinggi. Kenapa? This is to prevent high wave or so the water not spill or not allow water to enter or to flow. Kita nak halang gelombang tinggi ataupun supaya air tidak tumpah, air tidak masuk. Alright, okay, next. Our option, so our choice, kamu nak pilih yang mana? So from all the characteristic, we choose W. Okay, why? Because it is located at the bay, has sloping retaining wall, uneven surface and high retaining. So this is the combination, mark number 10. If we get here all correct, okay, or here also all correct, so you are granted with mark number 10 combination. Okay, so if you mark this should be your first mark, M1, this is M2, the reason, mark 3, mark 4, mark 5, mark 6, mark number 7, mark number 8, mark number 9 for correct choices, and mark number 10 is for combination of characteristics. So if we go back to the table just now, student, you can also use this method first. I call it as a tick to pick method. You can tick earlier. Okay, which one? So we choose at the bay. Okay, we choose at the bay, sloping retaining wall, uneven surface, and high retaining wall. So you can see, obviously, the answer is W, because it fulfill all the characteristic required for the retaining wall. Okay, so I guess that's all for tonight. Cikgu rasa setakat ini saja untuk malam ini. Alhamdulillah, kita telah berjaya habiskan kelas dalam 9:30 malam. Sebelum itu, cikgu kongsikan dahulu link kepada e-Sijil Express. Nanti anda boleh isikan menggunakan nama seperti dalam kad pengenalan. Isilah dengan semua huruf besar supaya dia nampak cantik dekat sijil tu. Dan nombor kad pengenalan masukkan tanpa sempang, without dash. So ini adalah sijil dia, anda boleh klik pada pautan sijil. So cikgu rasa itu saja untuk malam ini, Refraction of Wave 5.4. So student, I hope this session will help you to have a better understanding on this chapter. And insyaAllah semoga kita berjumpa lagi pada minggu hadapan for the next topic 5.5, diffraction of wave. Jadi segala yang baik itu daripada Allah, segala yang buruk itu daripada kelemahan dan kedangkalan ilmu saya, tapi hakikatnya semuanya daripada Allah SWT. Terima kasih di atas masa yang anda luangkan pada malam ini, sama ada cikgu ataupun murid-murid dari mana jua anda berada. Thank you very much for joining me tonight. Again, I hope this session help you to understand refraction of wave in a better way. InsyaAllah kita berjumpa lagi dalam masa yang akan datang. Assalamualaikum, salam sejahtera. Selamat malam. Bye-bye semua.
Mara semua para ilmuwan, semai ilmu kepada anak wawasan, tak kira di utara selatan, sampaikan ilmu penuh kesungguhan. Akademi Youtuber Malaysia, rangka laksana dengan jitu, penuh bermisi guru AYU, mencapai misi yang satu. Permisi kita, bantu kita, bermoto sendiri yang kita biasa, bersama kita luar biasa, berjasa demi nusa bangsa.
Akademi Youtuber Malaysia, berpadu bersatu keluarga AYU, memberi ilmu tanpa jamu, siap sedia menyumbang ilmu.
Ilmu diberi juga dikongsi pada semua generasi yang terkini, lahir generasi yang berkualiti, sedia berkhidmat pada pertiwi. Akademi Youtuber Malaysia, rangka laksana dengan jitu, penuh bermisi guru AYU, mencapai misi yang satu. Permisi kita, bantu kita, bermoto sendiri yang kita biasa, bersama kita luar biasa, berjasa demi nusa bangsa. www.academyyoutuber.com. Berusaha AYU capai kecemerlangan, berpadu AYU cipta kegemilangan, bersatu AYU bina wadah terbilang, terus berjaya bersama AYU.
Berusaha AYU capai kecemerlangan, berpadu AYU cipta kegemilangan, bersatu AYU bina wadah terbilang, terus berjaya bersama AYU.
Mara semua para ilmuwan, semai ilmu kepada anak wawasan, tak kira di utara selatan, sampaikan ilmu penuh kesungguhan. Akademi Youtuber Malaysia, rangka laksana dengan jitu, penuh bermisi guru AYU, mencapai misi yang satu. Permisi kita, bantu kita, bermoto sendiri yang kita biasa, bersama kita luar biasa, berjasa demi nusa bangsa.